Unit 1 Introduction to Compiler. The code is RCS 602. The first topic we will discuss about phases and passes. First, we will discuss about language processor. A compiler is a program that can read a program in one language, the source language, and translate it into equivalent in another language known as the target language. Compiler receives the source program as an input and target program as an output. An important role of the compiler is to report any kind of error in the source program that it detects during the translation process. If the target program is an executable machine language program, it can be called by user to process inputs and produce the outputs. Target program When the target program is generated, input can be taken and the corresponding output can be given. An interpreter is another common kind of language processor. Instead of producing a target program as a translation, an interpreter appears to directly execute the operation specified in the source program on the input supplied by the user. So interpreter can take source program and input as a input of the interpreter, and corresponding output will be given. The machine language target program produced by compiler is usually much faster than the interpreter at the mapping inputs to the outputs. The interpreter, however, can usually give better error diagnostic than the compiler because it executes the source program statement by statement. Let us discuss one Java language processor. Java language processor combine the compilation interpretation as in figure. You can see here there is a translator. Translator receives the source program. Translator provides intermediate program as an output, and intermediate program input is given as input of the virtual machine, and corresponding output is given. It is also known as the hybrid compiler. A Java source program may first be compiled into intermediate form known as the bytecodes. The bytecodes are interpreted by virtual machine. The benefit of this arrangement is that bytecode compiled on one machine and can be interpreted on another machine across the network. That is the machine independent. You can see here we have language processing system. Source program can be given as the input of preprocessor. Modified source program is given as output of the preprocessor, and this modified source program is given as input of the compiler. So the responsibility of preprocessor is to expand the macros, remove this blank space, etc. And the modified source program is actually fed into the compiler. Assembly language is then processed by the program known as the assembler. An assembler provides the relocatable code may have to be linked together with another binary files or library files. The linker resolves the external memory address where the code in one file may refer to the location in another file. Structure of compiler. uh, when we uh, Up to this point, we have treated the compiler as a single box that maps the source program semantically equivalent target program. But we open that if we open this box, we will see that compiler is divided into two parts: analysis part and synthesis part. Analysis part breaks up the source program into number of pieces which is imposed by the grammatical structure on them. Then it use the structure to create the intermediate representation of the source program. If the analysis part detects the source program uh, in wrong form, then or semantically unsound, then it must provide some informative message to the user for the corrective option action. The analysis part also collects the information about the source program and store its data structure called symbol table. Now the synthesis part. The synthesis part constructs the desired target program from intermediate representation and the information in the symbol table. The analysis part is often called front end of the compiler. The synthesis part is the back end. If we examine the compilation process in more detail, we will see that it operates as a sequence of phases, each of which transforms one representation of source program into another. A typical decomposition of compiler into phases is shown as the figure. Figure you can see here. Several phases may be grouped together, and intermediate representation between the grouped phases need not to be constructed explicitly. A symbol table which stores the information about entire source program is used by all the phases of the compiler. The compiler have machine independent optimization phase between front end and back end. The purpose of optimization is to produce the better target program that would have otherwise produced from an unoptimized representation. Lexical analysis. The first phase is called lexical analysis or scanning part. The lexical analyzer reads the stream of character making up the source program and group the character into meaningful sequence called known as the lexeme. Each lexeme's lexical analyzer produces an output a token of the form token name and attribute value. It passes on to the subsequent phase known as the subsequent phase syntax analysis. In the token, the first component is the token name, which is the abstract name that is used during the syntax analysis, and the second component is the attribute value, that is the entry in the symbol table for this token. For an example, position equal to initial plus rate into 60 can be used for phase analysis. So for example, we take position equal to initial plus rate into 60. The characters in this assignment could be grouped into the following lexemes and mapped into the following tokens on the syntax analyzer. Position is the lexeme that would map with the token. Since the position is id, so id comma 1 is given here. Symbol table entry for the position. The symbol table entry for an identifier holds the information about the identifier such as the name and type. Second is assignment operator. It is abstract, so it does not have any attribute value. Third is the initial, it is id, so this is the second id, so I can write id comma 2. This is the part. Next is plus symbol. Plus symbol is a lexeme that mapped into the token plus. Third is the rate. This is the third id, so we should write token id comma 3 where 3 points to the symbol entry of the rate. Next is asterisk. It is abstract, so only asterisk can be represented in the greater than or smaller than symbol. 60 is the lexeme that is mapped into the token. Blank separating lexemes would be discarded by the lexical analyzer. So now we have id comma 1, that is for position, assignment operator, then id comma 2 for the initial, plus symbol, then id comma 3 for the rate, multiplication symbol, and 60. Here token names, assignment operator, plus and multiplication are abstract symbol for the assignment, addition, multiplication operator respectively. After lexical analysis of the position equal to initial plus rate into 60, the sequence of token can be represented as follows in the next slide. So here we have position equal to initial plus rate into 60, character stream we have here. Next we have lexical analyzer part. We have token stream, and token stream can be written as like this. We have already discussed. This is syntax analyzer. It creates the syntax tree. You can see this is very easy to understand. Semantic analyzer. Semantic analyzer will check. So 60 is converted into integer to float. So now we have intermediate code generator. Intermediate code representation will be represented like this. It's very easy to understand. We have temporary variable t1, t2, and t3, and finally the result is stored in the t3. Code optimizer will optimize the code. It can be optimized like this: number of variables or number of temporary variables are removed. Here we have the code generator, and finally we have the target machine code. So this is the translation of assignment statement. Next we have semantic analysis. Semantic analysis analyzer uses syntax tree for the information in the symbol table to check the source program for the semantically consistent. Next we have type checking. Next we have position initial and end. All it is have been declared as the floating point. It must be declared as floating point. Lexem 60 by itself is the integer. An intermediate code generator, you can see it's very easy to understand that there can be the three address code, two address code, which will be discussed further in the next unit in detail. Next we have the code optimization. Machine code optimization can be machine independent code optimization or simple code optimization. Code generation is here. Thank you. Next will be discussed in the next class. Thank you so much.